Okay, welcome back, everyone. And one of the clear Gen AI successes is leveraging AI for software developments. We have Patrick Dubois, godfather of DevOps, giving us more insights in AI native developments, going beyond using just GitHub Copilot. With this, Patrick Dubois, welcome on stage.
Thank you, Sophie. Let's get started. We only have 20 minutes, so lots of slides. Let's go ahead. Right, so AI native development, that's what we're going to center about. Most people know coding, Copilot, that's the most main thing, but it is part of a bigger thing, and that's what I want to go through. I'm going to go through a couple of sections. Like one is kind of more delegated coding. Then we're moving into specs with more context, and eventually we're going to delegate the trust, become more autonomous with human oversight. I'm working on these principles as part of the AI native dev community. You can join us, go to the website, listen to podcasts, or if you're in New York, join us for one of the meetups right now. But this is kind of all work in progress. So please join us and have a discussion with that as well. Right, first part, delegated coding. That's what most of the people are focused on. And we've all seen kind of the initial thing of we write something in our code editor, we tap, go, and there's completion. Great work, but it doesn't end there. Then we got the chat. The chat kind of helped us generate the code. And then, that was working okay. But eventually we got it like, hey, whatever we generate, please apply this to the code. So we gave it a little bit more kind of from the side to what we want to do. There's even more things that the next step where a cursor is going to be predicted by AI. So if I complete one thing, it's also want to complete other parts. So this is another improvement that's been going on in the tools. Eventually, it wasn't one file, we became multi-file. Most of the code editors are now multi-file aware. They generate one file, multiple files, and do code edits in multiple files. Now, besides the code, we also learned that we can bring in the terminal feedback. If things fail, an error, we can ask it, we can improve it. So it's not anymore just on our code, but maybe also on the execution and not just in the terminal. We have the same actually happening with a browser. If there's an error in a browser, the coding tools can pick it up, we can improve the code, and that we get into that cycle of improvement. So that's great. Now, to become even better, it's not just generating our code, it's generating our tests, because part of this, as a good developer, is not about just writing that code. And the tools are helping now increasingly because tests is part of the code. Now, if you take everything into loop, we had kind of the company Cognition who released Devin, and that brought that into a continuous feedback loop. They have a browser, they have the code editor, they have the terminal. The system actually looks at the output and you can give it something to do, something to code. So that kind of loop is now getting a lot kind of tighter than just copying and pasting things in from the chat. Now, if you can go further, why have one coder? We can have one coder working on one part of the code base, another on another part. And so eventually that leads us to an AI team of agents that will kind of start coding for us. And if we take it up even a notch, whatever we coded, the tools can auto-optimize, even bringing this live and doing A/B testing and kind of impacting and changing the code. This is one of the tools that kind of helps there. So you see, from a simple thing, it's moving all the way up to code, a feedback loop, tight feedback loop of improvement. Now, that's all good for code generation. But the next part I want to tell you is we're actually moving away from the code to more specifications. How would it look like? Now, we saw the early signs of a little bit specifications when you put things in your prompt. In the prompt, you say, I want this to be coded as an expert developer in React or whatever language. That brings a little bit of kind of extra into the mix. Now, you can set your own rules, how you want things to be coded. That is another thing that starts appearing in the code editing tools, is you bring in your style, the way you want things to be done. Okay, that's still quite code-centric, how we do things. Now, it doesn't have to be just the code. We can also specify which components it needs to use, which in this case, the front-end components. And we can bring a broader thing, not just how to build or what the code looks like, but we can bring in design, like upload an image and say, this is what I want the front end to look like. So another way of specifying what we want instead of just saying, this is how it should look in code. Now, we can keep track of all those features, and people have started doing this almost in a Markdown file as part of their code. And it brings up the features that it's improving, the way normally people type this into their prompt, but they're now part of a more kind of elaborate description of what people want. Now, this feeds into task plan, like GitHub Code Workspaces. You give it a task. You're not saying anymore how it should be coded. Well, we did a little bit before, but now we're getting towards the intent of what we want it to be doing. And that's kind of the difference between kind of we're focused on the coding, and then we're moving towards the intent, and then we hope the machines eventually create the code that we wanted to create. Now, tools are emerging in that space, more from product requirements document, and you see just describe what you need, and eventually it generates it with the frameworks we want. That's one way. A more specification centric, because it's going to be a spectrum from a Markdown file to a fully fledged kind of a description of all kind of the requirements. And then eventually we want to jump between them. Like if we change something in the code that we think isn't right, then we wanted to alter the specifications. If we change the specification, we wanted to alter the code. So that bidirectionally is what tools are striving to go for. Now, this is all quite interesting that we're getting more into specifications, but specifications and just the coding engine are not enough. Lots of the time, developers actually have a lot of context. And so what you see is that there's a third piece of bringing in context into those tools. Now, we had a little bit of that by bringing in other files and other things in kind of the code editor. We can bring in outside code in as like optimized for the prompting that we're doing. These are kind of experimental tools that people are using. And we can bring in documentation. This is not RAG, but it's just bringing in a similar thing, like all this information on how to code in a certain framework, best practices, we can bring them in as documentation. We can bring in any doc because those tools are emerging. Just take a doc, a URL, and convert it to context in my code editor. And we can just keep adding, whether that's our code, our terminal, or wiki, or issues, or logs. It just all becomes more context for those tools. And we can kind of start thinking about how we optimizing actually our code or documentation or everything that we know for bringing in the context of that coding. And eventually, the tools are starting to also say whatever it's generating, that becomes knowledge. And that, again, becomes context, and that can be part of, useful for putting the specifications towards a coding generation. And we can even go a step further where they take this knowledge and they help other humans to navigate the knowledge. In this case, a PR review, and it has all the knowledge, and it starts helping the people who have to review them. So you see, we're moving towards specs and more context and the coding tools. Now, this is all good, but eventually we want to have that thing do this autonomously for us. So what we're trying to do is to delegate part of this as the trust that we're going for. Now, the tools start earning our trust. And sometimes that's internally when tools generate code, they do a runnability check. Is that code is not just being generated, but they try to run it and they try to run the tests. And in this case, it gives us a better chance of understanding that it's actually good code. So it kind of earns our trust by doing these additional checks. Maybe it notifies us for changing API docs. So it's not just generating any code, it actually also watches that it doesn't break any of the existing APIs or the versions or stuff that we put in there. And if we're going to go a step further, we're almost thinking about much like guardrails for APIs, there's guardrails for code generation. Is the code becoming too complex? Is the code still familiar for the developer? Does the code coverage increase when we adding things and not decrease. So all the guardrails that we already have in place right now for a traditional developer can be reused for AI agents to generate the code. And then also security, it could do auto threat modeling, it could explain us what it's doing, and it could help us get better code and more secure code in there. Now, the question is, do we trust, as a developer, these systems to commit and deploy automatically? Some of the tools started doing auto commits. If it feels that it's certain about what it's going to do, it's already auto committing. So it's almost like a threshold of certainty or trust that we want the system to act on our behalf. This is a very simplistic example, but it shows you kind of where we are working towards too. Now, if we generate stuff, it's nice to do a rollback. So we see in most of the agent tools that we're having checkpoints of rollbacks, changes, roll back if it doesn't work. It's going to be tested, roll back if it doesn't work. So kind of those safety guards are being put in place for us to gain trust and to allow us to kind of deal with issues that are being done in a safe way. Sometimes we even want to say, AI, you cannot touch this file. This was an example of windsurf, where you see it's almost like an access control system that we're setting up like AI. We trust you, but not on this, not for that. It's almost like humans, we allow you to do this, but we don't allow you to do the other part. And as it's gaining our trust, maybe relax the controls. But for now, this is a nice way of putting things a little bit more control in there. The last part that I want to bring out is the human oversight. We brought in the context, we brought the specifications, we put it through our code engines, we asked them kind of to earn our trust, but still things might go wrong. There might be systematic problems. We have to keep the oversight. Now, obviously, that's going to be hard because the more this thing works autonomously, what do we still know as a human? So we want systems that are AI native development to actually help us keep that oversight. Now, what would it look like? As a developer, you were used to reviewing code in a div mode. Hey, something green has changed in this file. That's good. We could also have an explanation in the chat mode by what has changed, but it's very kind of elaborate and not that condensed. Now, here you see one of the tools suggesting another way of reviewing. So they take the change, but they actually kind of optimize it for human readability, because we're now producing more code as ever. So it's important that we reduce the cognitive load of the review by the human in new ways. So it removes the code that we shouldn't be looking at. It summarizes the code if it makes sense and kind of helps us grow through that phase. So it's one way of helping us as a human oversight to do this. Now, this likely doesn't scale because we can't review every line of code, but it is a simple example of that. Now, sometimes you want to have, like, first do a step, review this, then review the next step, then review the next step. This is kind of like focusing us again on what matters in small chunks of time, a typical thing of automation. And sometimes we want to give feedback, and we want to have multiple versions with failsafe, the rollback that I already mentioned on reviewing, and that we can kind of throw it in there as well. Now, we like to have instant feedback, right? If we really have to wait for feedback, sometimes that's annoying. So these things really want to help us and not be too much asynchronously on kind of us dealing with the issues. Different visualizations, like sometimes it's code, but maybe a diagram makes more sense to explain what it does. So another way of making it more explainable to a human what it has been doing. And then maybe it builds a code base, visualizes impact, like all different ways of helping us to review the code and understand the code, and also dealing with issues at hand when they happen. So this brings up the context, the concept of a moldable development environment. So it's not just your text editor, it's not your code editor, it will not just be your spec editor, but it kind of wraps itself on how the code and the domain works to understand and explain that to the end user on what the decision or what the error is they need to do oversight on. So this brought kind of like an overview of the different patterns. This is work in progress. Please join us in the community. Help us kind of refine this wording. Wordsmithing is important. If you see different parts that do not belong here that are important, please kind of help us have that discussion in the community as well. And with this, I want to say thank you. I'm opening up the floor for questions. You can watch my YouTube channel, and if you're interested in the slides, and I'm sure the video is going to be up, contact me on LinkedIn, and we can have a conversation. And if you have feedback, I'd love to hear it from you. And that's it. Thank you very much, and enjoy the rest of the event.
Great. Well, thanks so much, Patrick. I think we have a couple of minutes left, so maybe we can take some questions from the audience. I think there's a first one from Jack, who's asking which IDE is the most advanced and usable in your opinion.
Yeah, everybody really always jumps into the tools, and it's a race, right? Like whatever I say today is going to be a race tomorrow. I think a lot of people are looking at Bolt.new New right now, which is more of a platform of code generation, lovable for more prototyping. On the code editor themselves, I think Cursor is leading the way. There's a lot of forks and a lot of variations to that, but I think they are still kind of leading the difference. But that kind of gives you an idea on the different tooling where it fits in.
I'm curious, as you were sort of talking through it, going through your talk, I was wondering, like, what does all these like rapid advances mean for the careers of like young engineers that are just getting started?
Yeah,
I'm curious, like, if you would go back to your younger self, like, what would be your advice?
So the lessons from DevOps automation and in automation in general is, if you become the reviewer or the manager of an automation system, you have to know what good looks like, right? Because otherwise you cannot judge. Otherwise, it's like what they call the AI, slot machine. You just say, okay, right? That's it. Now, the problem then is, like, how do we get people up to the level that they understand what good looks like? And so the juniors, when I ask them kind of more of that question, they say, well, these tools actually help us become faster a senior on how good looks like. So whether that's training the people on the job continuously, telling them what's good and what's bad, having them try multiple things, the speed of that would be different than when I started my career, because the feedback was quite slow. I did not have like a constant tutor helping me, showing me good examples. So that kind of like helps a little bit to advance the career. But in essence, it's probably going to balance out. But what's definitely sure is that one person will do a lot more than what they do right now. So multiple people kind of might get reduced into the job of one person. Now, I advise people to kind of become either more of an architect of that overview, because that's part of that, or go into the product specifications, understand what the business needs, and start learning on that part. So that would kind of be my advice on those things.
Yeah. So less of the purely focused engineering, because a lot of that work is basically going to become more autonomous, or there will be less roles in the future.
There's still people debugging kind of the electrical grid, but on average, you just need to plug in. So that's kind of like how I look at it.
I think we've made time for one final question. The interesting question from Jelmer: What development has surprised you the most in the recent years?
I think that what I find fascinating is the fact that it's starting to take over our desktop. So it doesn't stay kind of only in our IDE, but it's trying to grab as much context as we want. What's on my screen? What are you looking at? Like, what should I do? And that kind of trend is very fascinating to see. Like, it doesn't need to understand all the domain languages, but it can adapt itself and kind of learn from examples of what we do. That's been the most fascinating for me, at least. So.
Great. All right, well, I think we're almost at time. So thanks so much for joining us on stage today. It was really fascinating. There's a lot of questions in the talk, but you've shared your LinkedIn, so I'm sure people can reach out. And to the audience, you can jump to the next call by using the redirect button on the bottom left. So see you.
Thank you.